And lastly, I'm going to go in and set up my remaining inlet. All right, so moving into my type L median drain, I'll do a quick review of the drawing, and then I'll move back over to my prototype and set that inlet type. Now for the gutter here, this is a median drain. So I'm not going to have that conventional type B gutter for this. So I'm going to be using a standard ditch section, and really the only requirement is that the ditch bottom width has to at least be the width of my inlet. Otherwise we'll get a message when we run a calculation that that dimension is less than. So what we'll do is we have two options here. We could define a ditch section in our gutter catalog to have to choose from, or we can do user defined here and type in that information ourselves. So we would just choose trapezoidal and then type in that information. And this is the method I'm going to recommend going with, as these ditches are likely going to be changing, and per project they could use a flex table to quickly go in and edit what those side slopes and width should be. So for the maximum gutter depth, I'm just going to go ahead and put in 1 foot for there, and then I'll do for my side slopes just something that's typical. So I go 4 to 1, 4 to 1, and then my bottom width needs to be at least the width of my structure. My grate width is 3, so that is going to be the minimum value that I can set my ditch bottom with here. And then for my head loss method, I'm going to leave that set to depressed. Next, I'll create a copy of that, and then I'll rename it, and really just going to be switching out the inlet type here. And one thing I do want to check is that my bottom width is what I need it to be, so I'm going to go into my inlet catalog and check that, and that needs to be 3 feet, so I'm good there. All right, next I'm going to be setting up my type M median drain. Now if I take a look at this type of inlet, I actually have a V-shaped grate. Now when I put in my gutter information here, I have to use a trapezoidal shape for a ditch inlet, and then this bottom width has to be at least the size of my grate width. So it's not going to let me do a smaller dimension here, or I'll get a message. So I'm going to assume a flat grate here, and that's going to match my structure width of 3.5. And then I'm also going to match the side slopes as shown on the drawing. All right, next I'm going to look at these curb only inlets, so I'll go ahead and configure those last 3. Looking at the type S, I'm going to keep using that depressed benching method with no sump. And I'm also going to be using that type B curb and gutter. Now one thing you want to check here is when you're changing it, make sure that you are getting the correct information. Sometimes you'll have to change it to a different setting and then back, and then that should pull the correct settings here. So you just want to make sure of that as you're doing your gutter types from a catalog. Okay, so I'm going to set my inlet type to a type S, the 4x6, and then everything else is going to be good here. And then I'll copy that prototype down and then just set the correct inlets. And then once you have all of your prototypes configured, that's when you're going to go over to your feature definitions and assign those prototypes to each one of your feature definitions. And this is where configuring your prototypes in the same order of your feature definitions is going to make this much easier to go through and assign these. And then same as we did with our prototypes, checking with the inlet types, you're going to want to go through and do a quick review, make sure you assign the correct prototype, as it's easy to select the wrong one. So you'll just want to double check that. When you're setting up your prototypes, we also want to consider the existing features. So if we're thinking about, conduits, there's not as many conduit feature definitions, so it does make sense to create a existing feature definition and prototype for each one of your existing types of conduits that you're going to have, and where we would set the design to not design. But for our node feature definitions, we have quite a bit for like head walls, catch basins, and our manholes, so a lot of times it doesn't make sense to duplicate our entire library. So I have taken the approach where I'm starting off small or generic, where I have an existing inlet for each type of inlet that I use, and then I'm using the most commonly used size to represent each one. So when I create these prototypes, I'm going to match up with that. So I want to take a look at my element templates. For a type B, I am going to be using this 4x4 type B. So to quickly get those settings, I'm going to copy my 4x4 type B down here and then rename it to my existing inlet type B. And then the only change I'm going to be making here is I don't want to design the structure. and then I'm not going to design the inlet opening. You might find you need to put a clogging factor on these existing inlets, but just do a quick review of all of the settings and make sure nothing needs to be changed. And I'm going to be doing that for each one. So again, I'm going to go and check and see what I assigned for that type. So that would be a 3x4. And then I'll go and find that one and create a copy of it. And then once we have those prototypes set up, I'm going to do a bulk selection of all these just to make it easier to assign since they're at the bottom. And then that'll make it easier to go through that drop down and assign the remaining ones.